Okay friends, so in this part we are going to use method of sections to find the forces in the members EF, FC and CB. In the previous part we already obtained the support reactions at C and D. At D we have minus 15 and at C we have plus 85. So we have already shown that. Plus there are two forces 20 and 50 kilonewtons. Now we are going to use method of sections to find forces in the members EF, FC and CB. So first let us take a section which will cut the members. Please note that the section should be taken in such a way that it does not cut more than 3 members. So let us take a section. We'll take a section like this. Now we are supposed to use either the lower part or the upper part of the section. Let us see that upper part of the section has only one force, that is 50. So it will be very convenient to use that. But it is alright even if you use the left hand side part of the portion which contains 20, 15 and 85. It is hardly going to make any difference. But still let us use a simpler one. We will use the upper part of the section. Now if you use the upper part of the section, we have to do it only with one force, that is 50 kilonewton. Now let us look at method of sections. We have to use moments. So let us look at a particular point at which a number of forces are coinciding. For example, if you look at point F, at point F the force EF and force CF are both coinciding. So if we take moments about point F, the moment of force EF about F will be 0, the moment of force EC about F will be 0, and the only force that will be left will be BC. So if we take moments of the force BC about point F, our job will be done. So that is the easiest way. So if we take moments about point F, we will be able to get the force BC. For that we will need to find the moment arm. So we need to find this distance from this particular point to this particular point, that is the moment arm of this 50 kilonewton force. So I think we have already done that in our previous exercise. We already computed this distance as 0.33. If you remember, this distance was already computed as 0.33. So all that is left is to find this particular distance. We will do that also. So see here, this was 0.33 and this distance AB is also 0.33. Let me draw a separate triangle here for our understanding. Let me take this point as M, this point as D. This distance is 0.33. This angle is 30. This angle is 90. So obviously side opposite to 30 degree will be half the hypotenuse, and the distance BM will be 0.17 approximately. 0.17. Actually it will be 0.167, something like that, but you can take that as around 0.17. So the moment arm of this particular force up to this point, particular point, this distance F, and say suppose this is M, this Fm will be 0.33 plus 0.17. 0.33 plus 0.17. Around 0.5. So distance of this particular point from here to here will be 0.5, and that will be the moment arm of A1. So moment of the 50 Newton force about point F will be 50 into 0.5. Now let us try to find the force BC. Now please note, only 3 forces will be considered: force in EF, force in FC and force in BC. The force in BC, let us assume it as tensile. Force in BC, we are going to assume it as tensile. Let us try to find how much this angle is. I think this angle is 30, this is 30, so this angle will be 60. So if we resolve the cosine component, horizontal component of FBC cos 60 will be along this direction. It will be along F. So FBC cos 60 will have no momentum about F. But look at this particular momentum, and that is FBC sin 60. The momentum of FBC sin 60 about point F will be 0.33. So we have got only two forces. One is BC sin 60 multiplied by 0.33 and 50 multiplied by 0.5. The sum of these two moments about F will be 0. So let us do that, and we will be able to find the value of FBC. Let us do this. We are going to take moments about F with a convention of clockwise positive. So we have 50 into 0.5, that is clockwise, plus FBC into 0.33, also clockwise, equal to 0. Sorry, FBC sin 60 into 0.33 equal to 0, and that gives me the value of FBC as 50 into 0.5 is 25 upon sin 60 into 0.8. Please do this calculation. Please do this calculation and see what we get. Obviously, it will be a minus sign. So we actually do the calculation and see what we get. I get 86.6. I get the answer as 86.6. Minus. That means I get the value of FBC as compressive and 86.6. Please note what I have done. I have taken moments about point F, so that the force EF has 0 moment, force FC has 0 moment. The only two forces is 50. I have computed this length as 1.5. So 50 into 1.5 clockwise. FBC cosine component acts along F, horizontal component. That moment is 0. FBC sin 60, the momentum is this length, which is 0.33. So FBC sin 60 into 0.33 and 50 into 0.5, both are clockwise, equal to 0. That gives me the value of FBC as minus 86.6. Now let us try to find some other forces. Now about which point do you think we should take the moment so that we will be able to get FEF? Let us take moments about point C. If we take moments about point C, you can take a look. FC also acts along point C and BC also acts along point C. So we will be able to get the value of FEF, isn't it? So let us take the moments about point C. by taking moments about point C, FC goes, BC goes, and we will get EF. So let me draw the situation here. This is EF. This force, please see I am drawing a horizontal line here. This angle is 30. So I have got two components of EF. This is a cosine component and this is a sine component. The sine component will act along C and it's gone. It's no value. Only cosine component of FEF, you can see it over here. This cosine component only will have a momentum, and this length FC we have computed as 0.577. We already know this length as 0.577. So we have one momentum FEF cos 30 multiplied by 0.577. It will be anti-clockwise, and distance of this particular point A up to points we already computed. This distance is 0.5. You can refer to the previous video, and this distance is 0.5. So 50 will have a momentum of 0.5 in the clockwise direction, and this will have a momentum of 0.577 in the anti-clockwise direction, and that's it. Only these two forces, and I will be able to get the value of F force in the member FE. So let us do that. Let us take moments about C. Again the convention of clockwise positive. So FE cos 30 into 0.577. This is anti-clockwise, so minus plus 50 into 0.5. And the sum will be 0. We are taking moments about C. We already computed the perpendicular distance from here to here as 0.5. So that gives me EF. Into 0.5 is 25 upon cos 30, 0.866 into 0.577. Please do this calculation and let us see what value we get for FEF. I'm getting the value as 50.03, that is almost 50. So that gives me the value of FEF as 50 kilonewton. So in this way we have computed FEF also and FBC also using method of section. Now what is left to be found is the value of force FC. Now if you want to find force FC, let us see about which point we should take the moments. If you take the moments about this particular point A, now please see, it's very simple here. EF will have no momentum because it is acting along A, so moment of EF will be 0. BC is also acting about point A, it has no momentum, so moment of BC also will be 0. This 50 kilonewton is also at point A, it has no moment. So obviously the only force remains is FC, it will not have any moment, nothing to equate because everything is getting 0. So Fc also will be the value of Fc will be 0 and Fc will be a 0 force member. Let me elaborate one more time. If we take moments about point A, force EF is acting along A, so has no moment arm. BC is acting along A, has no moment arm. 50 is acting along A, has no moment arm. So the only force that is left is Fc. Obviously, if you take the moment of Fc about point A, there is nothing to equate to because all the three other members have 0 moment. So obviously, the force Fc also will be 0. So Fc will be a 0 force member. Fc, the value of Fc will be 0. So we have computed EF as 50 Newton positive, BC as minus 86.6, that is 86.6 compressive, and Fc as a 0 force member. So in this way, we have elaborated the method of sections for EF, Fc and BC. You can also use the method of sections to find the forces in the members EF, EC and DC. So let us try to use the method of sections for this particular section. See, I am drawing this section here. Let us forget about everything else. We will consider only this section now, and we will consider only left hand side. There are only two forces, one will be 20 and one will be 15. So I am erasing everything else. We will also get EF when we will verify that the answer is 50. We will also get EC and we will also get DC. DC we already computed and the answer was, I think, 30. So let us see, verify if we are getting the same answer. So what I am doing is, I am going to erase the right hand portion of this particular part. Let us get rid of this particular part. So we are considering EF, we'll consider EC and we'll consider DC. Alright friends, now I think if you want to find FDC, then we have to take moments about point E. If we take moments about point E, EF will go, EC will go, and the only thing that will be left will be DC. I think we have already computed the vertical distance. This vertical distance we have computed as 0.289. We already computed. So the momentum of DC about point E will be 0.289 and momentum of 15 Newton about point E, this particular distance, we have computed as 0.5. So let us take moments about E with the convention of clockwise positive. 20 will have no momentum about E because it is acting along E. So 15 is acting in the anti-clockwise direction about point E. So minus 15 into 0.5 plus FDC. Now it is also acting in the, you can see the force is here, it is going here, so we are going to take a turn like this which is in the anti-clockwise direction. So minus FDC into this distance is 0.289 equal to 0. Let us do the calculation and get FDC as minus 15 into 0.5 upon 0.289. Please do the calculation. I'm getting 25.95, that is 26, and obviously it's a compression because the answer is negative. It is in conjunction with what answer we got previously. It was 25.95. Now please tell me, how will you obtain the force EF, about which point you should take the moment so that you will be able to get force EF, and of course the answer is point C. If you take moments about point C, moment arm of DC will go, moment arm of EC will go, and the only thing that will be left is EF. So we will be able to take the moment of EF about point C plus this 15, and we should get the answer. Let us do that. Now before we take moments about point C, it is necessary to resolve the force EF. So let us resolve the force EF. You can see here, this angle is 30 degree. So one resolution is FEF cos 30, and the other will be here, and that will be FEF sin 30. Both of them will have moments about C. FEF cos 30 will have a moment arm of 0.288 or 289, and this particular point will have a moment arm of 0.5. Distance from here to here is 0.5. Distance from here to here is also 0.5. Plus 15 Newton will have a moment arm of 1. So let us take moments about C. With the convention of clockwise positive. Let us do that. FEF will have a clockwise moment, so it will be positive. Positive moment. EF sin 30 will be anti-clockwise, it will have a negative moment. Multiplied by 0.5. And last, it is 15 will have again an anti-clockwise moment with a moment arm of 1. Equal to 0. See this equation. This particular equation, if you solve, we should be able to get the value of EF. Let us do this quickly so that please you also do the calculations. I am also doing it. And I am getting the answer as 15 upon FEF this 20 kilonewton also will have to be taken a moment, I think that I have missed. So this 20 multiplied by 0.5 will also come into picture. So let us see here. I made a mistake in the resolution. I'm extremely sorry. I will have to redo it again. Please bear with me. I will have to redo it again. It's my mistake while resolving the forces. I'm extremely sorry. Let us see here one more time. This resolution was, sorry, it has to be in the upward direction. Sorry for misleading you. Let's do it here. This force EF will have one component of cos 30 and the other component will be sin 30. Both will be in the upward direction. So now let us take moments about point C. FEF cos 30 into 0.289 clockwise. FEF sin 30 is upward, that will also be clockwise. So plus this 20 will have a moment arm in the anti-clockwise direction. And 15 will have a moment arm again in the anti-clockwise direction, and their sum will be 0. So that should give me the value of FEF. So let us do the calculations. I'm getting 49.9. That is almost 50. It is in conjunction with our previously calculated answer for FEF. So see what we have done. We have taken a section. The forces to the left are 20, 15 plus the three forces which are going to be cut, this one and this one. Since we are taking moments about C, EC and DC will have 0 moments. The only force which will have moment is EF. I have resolved in two components. One is cos, other is sin. The cos component has a moment arm of 0.289. The sin component has a moment arm of 0.5. 20 downwards has a moment arm of 0.5. 15 downwards has a moment arm of 0.5 plus 0.5, that is 1. I have used the convention clockwise positive, taken moments about C, and this is the moment equation, and that gives me the value of force EF as 50. So I think that is enough to elaborate on method of sections. In our next video we will see some more examples on method of sections.